The room is silent. It is September 1999, and the Jet Propulsion Laboratory is holding its breath. Every eye is fixed on the monitors, waiting for a signal from the Mars Climate Orbiter. But the silence remains unbroken. The signal never comes. That silence cost $125 million. It was a mission designed to revolutionize our understanding of Martian weather. But instead, it became a cautionary tale. How does a project of this scale simply vanish? The answer lies not in a dramatic explosion, but in a quiet, invisible interface. It was a failure of communication, a bridge built in two different worlds. Imagine two teams designing a structure from opposite ends of a canyon. One side works in inches, the other in centimeters. They never meet in the middle. The Mars Climate Orbiter was a triumph of human ambition. Its blueprint was a masterpiece of solar arrays and gold foil. It was meant to be the eyes of Earth on a distant red world. But deep within the ground software, a hidden mismatch was already taking root. It was a simple, subtle error. One system calculated impulse in pound-force seconds. The other expected Newton seconds. Neither side realized the other was speaking a different language. This is the danger of unmanaged assumptions in complex engineering. When data passes through a system without validation, it carries the weight of its own origin. The orbiter approached Mars, its trajectory set by math that did not align. It dipped too low into the atmosphere. The heat intensified. The spacecraft was lost to the dark. It was a stark reminder of the necessity of verification. Precision is not just a principle for engineers. It is a lifeline. Without it, the machine becomes a ghost. We often look for villains in stories of failure, but there were no villains here. There were only fragmented processes and a lack of clear ownership. The investigation that followed revealed a stark, simple, and painful truth. A single unit mix-up had doomed a $100 million mission. It was a lesson written in the debris of a failed orbit. The cost was high, but the knowledge gained was invaluable. It forced the aerospace industry to look harder at its own invisible bridges. We must ensure that every interface is a point of clarity, not a source of confusion. The silence of the orbiter remains a powerful echo. It tells us that even in an age of space travel, the smallest detail can change everything. We build our future on foundations of data, and those foundations must be absolute. The mission to Mars was a loss, but it remains a critical chapter in our history. It reminds us that our reach into the stars is only as strong as the math that guides us there. We must always verify, always question, and always communicate. Because when we reach for the heavens, we cannot afford to lose our way in the conversion. The story of the orbiter is a story of human error, but also of human growth. We learn, we build again. We reach further than before. The silence of 1999 is now a foundation for the precision of tomorrow. We owe it to the mission and to the future to never stop checking the units that lead us home. The silence was absolute. In the control room, the air felt heavy. Every engineer knew the stakes. They had built this for years, pouring their lives into the code and the metal. Now it was all down to math. When the signal failed to arrive, the shock was palpable. Nobody moved. Nobody spoke. The silence was not just an absence of sound. It was the weight of $125 million vanishing into the cold Martian night. Before the silence, there was pride. The Mars Climate Orbiter was a marvel of engineering. It was designed for a grand purpose: to study the Martian weather and unlock the secrets of the planet's atmosphere through long-term observation. The engineers worked tirelessly. Every component was tested, and every system was checked. They thought they had accounted for every variable. They did not know that one small error was hiding in the digital architecture, waiting for its moment. The error was in the ground software, a simple unit mismatch. It sounds trivial, but in the vacuum of space, small things have massive consequences. It was a failure of communication between two teams of brilliant, dedicated engineers. One team used imperial units. The other used metric. They were working on the same spacecraft, for the same goal, but using different measurement systems. The data was passed along, and the error was never caught by anyone. This error became part of the software. It lived in the code, hidden from the eyes of the testers. It was a silent passenger on the journey to Mars, waiting to manifest as a catastrophic failure at the end. As the orbiter approached Mars, it began its orbital insertion maneuver. The thrusters fired, but based on the wrong data. The spacecraft was pushed into a trajectory that would take it much closer to the planet than planned. The atmosphere was thin, but at those speeds it was like hitting a wall. The orbiter felt the drag. It struggled to maintain its altitude, but the math was wrong, and the fate of the mission was sealed. The signal was lost. In the control room, the silence returned. This time, it was permanent. The mission was over, and the investigation began. Engineers searched for the cause, turning over every piece of data they had collected. They traced the data back to the ground software. They found the unit mismatch. It was there, in the code, simple and undeniable. The realization was a gut punch. $100 million lost to a unit conversion. The report was clear. The failure was avoidable. It was a failure of systems, not people. It was a reminder that even the most advanced technology is only as good as the processes that support it and the communication. We learned a lot from that day. We tightened our protocols. We improved our verification processes. We made sure that such a mistake would never happen again. The cost was high, but the lesson was learned and integrated. The loss of the orbiter is a part of our history. It is a story of failure, but also of progress. It is a reminder of the fragility of our ambitions and the strength of our commitment to overcome obstacles. We continue to explore. We continue to build. We continue to reach for the stars, and we do so with a deeper understanding of the importance of the details, the units, and the bridges we build between our teams. The memory of the orbiter lives on. It is a silent sentinel in the annals of space exploration. It reminds us that our reach is vast, but our grasp is only as good as the precision of our work. We will return to Mars. We will continue to study its weather and its secrets. We will do it with better software, clearer communication, and a renewed commitment to the absolute accuracy that every mission demands of us today. The orbiter was a loss, but it was also a beginning. It marked a turning point in how we approach software development for space. It forced us to grow, to learn, and to be better than we were before. We owe it to the future to remember. We owe it to the past to learn. And we owe it to ourselves to keep reaching, keep building, and keep pushing the boundaries of what is possible in the vast unknown. The Mars Climate Orbiter is no longer just a failed mission. It is a lesson. It is a reminder. It is a part of the journey. And in that way, it remains a part of our success in space exploration. We carry the lessons of 1999 with us every time we launch. We carry them in our code, in our tests, and in our mission designs. We are better, stronger, and more precise because of what we went through. The journey to Mars is long, and the path is filled with challenges. But we are ready. We have learned. We have adapted. And we are moving forward, one mission at a time, to the secrets waiting in the dark. We will never forget the lesson of the orbiter. It is etched in our history, written in the code of our success, and carried in the hearts of every engineer who dreams of exploring the red world above us. The red world waits. We have the technology, we have the passion, and now we have the wisdom. The future of space exploration is bright, and it is guided by the lessons we have learned from our past mistakes. So, keep looking up, keep asking questions, and keep pushing the boundaries. And remember, every detail counts in the quest to understand our universe, because that is how we reach the stars and eventually call them our